So I'm going to actually go through one case study, and this is one that we use a lot, actually, when we talk about our platform. And it's just to kind of get people thinking about it, and then what I'll do is I'll kind of, we have sort of a second part, which is to, where I present another company, and to think about, okay, well, how do I then apply the methods we have just talked about to solve these problems? So the people who, you've seen this before. So Cydyne is not a real company, but it is based on real people and real company. But basically you have, the common scenario is you have a small team. The team does not necessarily have a machine learning person on board. A lot of companies try and centralize their machine learning and data science groups into one team, but that's never really a good idea. The reason for that is you don't want your data science people to be disconnected from the business unit. It's better to embed your data science people in with the actual team, with the actual analysts. The problem is that oftentimes the data analyst needs to, the data scientist needs to understand the mechanics of the problem. But typically organizations are broken down in small units, and in this case you have a lead, you have somebody, she's a conventional engineer, she doesn't have any machine learning experience. So the problem that they have is they're under, like many companies, they're under cost control. So they have, there's something called a, so one of the things that most companies have for their products is that they have forums where people can bring up complaints, they have questions that they're asking, they're looking for help on topics. But if the forums are not effective, then it means that people are going to be calling the help desk instead. And so in this case, what happened was that the forums were taken over by trolls. And so when people would come in, they would start to make comments about all kinds of things and really unpleasant things. And so the forums became less and less useful. And their product was deployed widely enough that it wasn't as though that you could say, hey, you know what, I first need to verify you're a customer before you can sign on to the forums. So it was not something that could be controlled that way. And so they had moderators, and so they could kick people out. And so through that, they could build out their training set, interestingly enough. But what happens if the moderator pool is shrinking? And that's an issue. So the business impact of this was that support costs increased dramatically. And so one of the reasons was that instead of going through the forums, people were now calling the support desk. And so that increased the amount of support calls. And then the second part was that because the support couldn't scale, the quality of support decreased, and so they started to lose customers. So it had a real material impact on the company. It was not just simply that, yeah, this is unfortunate, people are pissed off, and that was it. It was really the fact of the bottom line. So this is a little bit of like, hey, self-promotion to some extent, but basically what the way that they solved it was, I mean, you can solve this by looking at your pool of, you already have the training set, because you had the people who were acting as moderators, and they would be marking comments as either being offensive or not. And so over time, they had enough data accumulated saying that this was an offensive comment versus this was not an offensive comment. This can be scaled to a lot of different types of problems. So for example, we're working with one Korean company that has a huge, they have, of course, a call center where people come in, they can ask questions, they have complaints, they have all kinds of issues like that. And so what they want to be able to do is classify that. But since they have a lot of training data already, because they've classified something as being a complaint, a question, a billing issue, or something, you can now automatically classify any incoming call So what you do is first transcribe it. So somebody calls it, you use an NLP system to actually transcribe that into text. And then that text can then be put through an AI, and you can also already automatically determine whether it's a question or a Boolean question or something like that. So same principle. And then the outcome, people came back. So going back to like how we think about it. So what is the problem? And so the first thing you do is you start off with a description that you would state it as a friend. Like how would you actually describe it to a friend? This is sort of the starting point for all machine learning problems. It's like if you can talk about it to a friend or describe it, that's probably, that's a statement that you can make, and that's your starting point. So in this case, for example, I need to know which comments on our forum are offensive or not. Simple statement. So then the next part is to formalize the problem. Firstly, identifying the task. So the task is simple, is to classify a comment as either appropriate or not. So that's your T. Your experience, which is like, what is your training set? Well, this training set is a collection of comments classified as appropriate or not. This was collected by the moderators for this forum. And then finally, determining the performance criteria. So for example, in this case, it could be that, well, your moderators are at least 80% accurate. That's what you want your AI to be. And there could be a bunch of other performance criteria. But you have to have, essentially what I've done is I've specified a T, I've specified an E, and I've specified a P. So that's kind of like when you define a problem, think about it in those three elements. So then the next thing is identify the assumptions that go into your problem. So part of the challenge is that a lot of times machine learning problems, if you leave it to the hands, this is why, going back to why I believe data scientists should be embedded in your business analyst teams, is because domain knowledge is often needed. And so it's not enough that somebody can just simply go in and say, hey, you know what, I can uniquely solve the problem. You can't. Very often you need, if it's a medical problem, you want physicians to be involved in the process. If it's a scientific problem, you want a scientist involved in the process. So part of that is you need oftentimes domain-specific knowledge. So part of that is, and the other side is really common sense, which is have a set of assumptions that are built into that. So here are some examples. So if you have the next word, so specify words, and so if I have a comment, so what are things that you think might be true about that statement? Well, you think that certain words might matter. You might think that maybe the demographic of the writers matter. Why is that important? Well, if I have a young person, they typically speak differently from somebody who's in their 60s. If, for example, a young person says, this was the bomb, this is very different from an older person saying this bombed. It's like, it means two different things. So understanding the demographic is very important. Who are you actually focused on? Another example would be these physicians in Essen, they're working on an image. And so they're saying, hey, we want to build a model. Okay, well, is your model applicable? Does age matter? Like if it's a child versus an adult, does it matter? Is it something where you can understand, does demographic matter? Is the person fat or slim? Because sometimes you can mistake fat for other things, or your system may not work as efficiently. So all these different criteria need to be thought about. Then the other thing is there a time element? So for example, older comments become less relevant than new ones. Part of that is because language changes, and another part is that themes change, topics change. An example would be in gaming. So if I build a forum around games, maybe there's some new mods that were introduced. Maybe the game has changed over time or something like that, in which case you want to discount older comments and you want to add newer comments there as well. Even in the medical space, for example, instruments may have a higher level of accuracy over time, in which case you want to retrain the model. So there could be a time or temporal component to your underlying data. So part of that is like understanding questions that can be tested by the real data. So going back to the medical example, is can I build an AI? Will my AI be applicable to young people? Well, part of that would be, okay, well, does a PET scan from a child look different from a PET scan from an adult? Are there significant differences that could confuse an AI? Another example could be that, so in your example could be, does heart rate have an impact on how accurate the model is? So can it confuse, for example, an arrhythmia for just somebody who has a naturally faster heart rate? Then also part of that could be identifying ways in which your model can be challenged. So which means that one of the things to think about is that when I release a model, because AI, deep learning systems are primarily black boxes, and it will be for a long time, and honestly, I don't believe there'll ever be a case where machine learning will completely not be a black box, in which case you need to understand the empirical aspects of your model. So the empirical aspects of your model are things like, when you talk about it, it's like the characteristics of your model. So you need to describe when do you think your model will fail or will topple over. So for example, I might build a model for adults in a certain category, but maybe it's certain age groups. I may want to, so understanding the scope of my model is really important. So it's not that I should just simply say, hey, I've got a model, then you can start using it. You need to be able to describe very narrowly where that model can actually be used. In physics, this is used a lot. Newtonian physics applies to gravity where gravity is very weak, and you're traveling a lot less fast than the speed of light. If you want to include the cases where gravity is very strong and faster than the speed of light, you move into relativity. So the next question that we want to do is like understanding similarity to other problems. As I said, I mean there are a lot of similarities with problems that you've already solved. Understanding, for example, doing any kind of text classification problem, it's related to each other. Sometimes it's hidden. An example of that is time series analysis. It turns out that there is a way for you to convert time series analysis into a classification problem with images. So sometimes if you work the problem a little bit, you can then figure out, well, how do I transform one data type to another to make it easier to use? An example of that would be with videos. With videos, it's essentially an image classification problem. There's nothing special about it. I don't need to build an LSTM to understand specific aspects of like I don't need to build a time series based on that. But if I want to understand a sequence of events, then it becomes different. And then the next question then, so for example, we looked at a case with CTs and PET CTs. PET CTs are essentially three-dimensional images. Well, when you think about it, aren't movies three-dimensional images? I mean, that's essentially what you're watching. It's a giant three-dimensional image where you're just taking slices of that over a period of time. So you can convert a three-dimensional image, in theory, into a movie. So these are the kind of things that you need to think about, that can I transform one data problem into another, something that I understand. So, and it turns out that in many cases you can. The molecule example is another example of that. It turns out when I work with proteins or genes, it turns out that these are nothing more than text classification problems. They can be boiled down to that. The transformation that takes you from a molecule to a piece of text is complicated and is highly mathematical, but you can boil it down to a text classification problem, which is a well understood problem. So, something to think about. So the next thing is understand the motivation of the problem. So part of that is, there is an element of politics involved. The question is, will your project be killed down the line? And the problem is that if your problem is going to be killed, if it's too expensive to solve, if it's if it's not solving an organizational need, I mean, I'm not going to spend a lot of time on that, but that can be a problem, that if you're not able to get the political motivation within an organization. And the second is that, well, probably the more important thing would be understanding, well, one of the things that's really important is to understand ROI on that. So solving a problem is great, but for example, let's say I have a task that's done really well by humans, and I want to automate that and get a machine to solve that problem. Am I really helping? Because maybe I'm like the human factor in that was one of the things that people like about your system. So an example of that is a call center. I mean, how many people have been really annoyed by one of these systems that says, hey, please state your question and whatever, and tell me whether it's a business problem or not. And it can be very annoying. So understanding what are you replacing? What are you trying to replace people? In which case, then you better hope that you're better than people in your problem. Are you trying to for example, with the physicians working on this medical problem in Essen, I'm not trying to replace a radiologist. What I am trying to do is add it as part of the decision-making process. So they want to use it as a filtering mechanism. So instead of having to analyze 500 images, they want to only analyze maybe 20, because only 20 are pathological, the rest are normal. So getting an AI would be used in that context. They don't care about the AI, they don't want the AI to then determine what specific pathology the person has, because that's what the physician will do. So and in fact, actually, sometimes you want that to be the case, because your training set may not have enough training samples. An example when you're talking about pathology is, in this case, you're talking about it's a liver disorder. There are many ways in which the liver can be damaged, but the thing is, if you try and finally group it into determining that, okay, well, this is potentially cancer, this displays metastasis, this is kind of cirrhosis in some form. They all may have, these are all pathologies, but you may not have enough data points to make any further differentiation beyond that. So part of the understanding is like, how does your data compare to what kind of problem you're trying to solve, and what is the impact? It turns out that if you can't, maybe there are some cases where if you can't solve that question that you're trying to answer, it turns out to be a useless problem. For example, maybe in some cases, determining whether something's pathological or not is not useful as a problem. Maybe you really do need to go down to the nth degree, in which case, you know what, your machine learning problem has suddenly become very expensive, because you're going to have to generate a lot more data. So then the next question would be, how is your solution going to be used? And this is a question about building any enterprise problem, but in particular your machine learning problem, because how is your data, where's your inference model going to finally reside? Is it going to be in the cloud? Is it going to be on premise? If it's in the cloud, do you have privacy issues that you're going to, because the cloud offers incredible scaling opportunities, but the patient data or information is going to be sitting in the cloud, or it's actually going to be transmitted to the cloud. So which means that could be an issue. Is it going to be a closed system? In which case, is it going to be on-premise? Do I have to put it on a device? All kinds of questions like that, basically. And then how is it going to be monitored? For example, when a AI has been deployed, you probably need to periodically test it to see, is it still coming back with the same results, or the same level of confidence. This is very different from an ordinary application. Like when you have an app that you've just deployed, you oftentimes don't need to worry about it that much because your app's not changing. And you're still going to get an answer out of that. But it turns out that with machines, with the machine learning problem, the problem can change over time, in which case your model starts to lose its accuracy. An example would be, suppose I have a model that I'm using to help producers write better headlines for newspaper articles. The problem is that over time, the news changes, in which case then it'll find that the model becomes less and less effective. So you need to be able to do these kind of assessments. And then finally, do understand how your model can be hacked. I mean, one example was Tay. I mean, you guys probably know about Tay AI. No? Well, there's a system that Microsoft built. So it was Tay AI, which was it was a chatbot that Microsoft built. And it started off in the morning as a 14-year-old girl with kind of talking like a 14-year-old girl with the same vocabulary and so on. And then at the morning, like the morning quote was, "Hey, I'm stoked to meet you. I'm very happy. I love the human race," and so on. Towards the end, it was like spouting like Nazi and right-wing propaganda, was endorsing Trump, all kinds of things like that. So it had literally over the course of the day. The funny thing was, Microsoft brought it down, and then a couple of days later, they brought it up again. And so again, it started off normal. A couple of hours later, it was trying to sell drugs. So the way that they did this, the way that the hackers they figured out that it was picking up phrases and concepts, and so it could be hacked that way. And so the question is, can your model be hacked? Another example could be with images. It turns out there's a very simple way to confuse an AI, because an AI ultimately looks at pixels. So if you introduce random noise to your image, it may be something that humans can't see, because humans don't look at it pixel by pixel. We look at it as a whole. And you can add noise to that and completely confuse the AI, because the AI does not look at it pixel by pixel, does not look at it as a whole, it looks at it pixel by pixel. So there are ways in which you can fool an AI. And in fact, in some cases, there could be ways to hack an AI. What happens if your training data is, suppose I want to defraud my company of millions, and I'm responsible for collecting the training data. The problem is that you don't have the same set of controls. Like Sarbanes-Oxley controls the core data that you're actually collecting as a company. But what about training data for models? Does Sarbanes-Oxley cover that? Probably not. In which case, I take a snapshot of my training data, and maybe I conveniently ignore all the kind of suspicious transactions so that my model doesn't know what a suspicious transaction looks like, or maybe a suspicious transaction of a certain type. So, and how do you then know that the AI will cover those scenarios? Because there's no easy way to determine that. So all of these things you need to think about it as a closed loop between your training data, the outcome, over a period of time, whether there's security constraints, the deployment target, all these things start to become things that you need to worry about. So then then the last part is really understanding the methodology to use, which is pretty much, this is the same thing. I'm not going to spend any time on this because this is type of stuff that you do anyway. But one of the key things that you want to do a lot of, and the key to a successful machine learning project is not to build one model and just let it go. The key to a successful machine learning project is constant iteration. An example is that suppose my training data and my real world data don't match, then you need to figure out, okay, well, what was missing? Suppose I'm not able to make any predictions at all. Maybe the time window was wrong. Maybe my assumptions are wrong. Very good example. When I'm doing a risk assessment on the financial markets, it turns out that's a very different problem than trying to predict the value of a stock. It turns out predicting the value of a stock is not really mathematically doable. You can actually prove that. Whereas predicting risk is something that is a little bit more predictable, and it is something that I can model. So it turns out that when we built a AI model to predict volatility on the volatility index, we were able to build a model that was 95% accurate. But we would never have been able to do that if we were just supposed to predict the value of a stock. However, there's a big however. There's a Berlin company that was working on stock prediction, and it turns out that with algorithmic trading, because you're talking about microsecond types of transactions, for a couple of microseconds, it turns out that the market is predictable, or you can build a model around that. But understanding what that horizon is very tough. And like what is predictable, what is not, where can your model actually lie? So that's another example. So running experiments is really important. You should be able to run one of the interesting things is also identifying the methodology to collect data. It turns out simulation is now a huge source of data. Nowadays, when they want to train a car, an autonomous vehicle, they oftentimes use games. So they actually run a car through a complex digital racetrack with lots of obstacles and things like that, so that they throw in there. However, you need to understand that this is a simulation, and, for example, do I have real-world lighting? So if, for example, if I don't have physical-based lighting, how accurate is my physical-based lighting in my simulation? All those kind of things start to play into the question. So an example of that would be a company that we're working with in South Korea. They want to train an autonomous vehicle. They would like to have, they're spending a ton of money on an AI to build the thing to test their AI. So to actually generate ground truth and to actually generate that information, because you need to then verify that the target environment that you're looking at actually is based on reality. The last thing is, of course, like keep somebody in the loop always.